Hello, Lighthouse family. My name is Mrs. Wills, and I am a 4th grade math teacher at the Indianapolis South Campus. What you're going to see today is an example of a student-led sprint, fluency practice, followed by concept development, and an example of what small group centers look like in my classroom. I hope you enjoy, and I hope you are able to get some takeaways from my best practices. Thank you. Good afternoon, boys and girls. How are you today? Good. Welcome back. I hope you had an awesome fall break. We're ready to get back to work. Today we are going to do a little bit more work with multiplication. I know we started our multiplication before we went on for fall break. Today we are going to be using addition, subtraction, and multiplication in multi-step word problems. So we're going to be using mixed operations and working through word problems with the different strategies that you've learned through Eureka Math. But what we're going to do to begin is we're going to start out with a sprint. So everyone should have a sprint on their desk. Make sure you start on side A. All right? We're going to get 60 seconds on side A. We're going to have it student-led, so one of our friends here in the class will go over that sprint. Then we'll have 60 seconds on side B. Remember, this is just for fluency. It is not for a grade, so try to do your best. Are you ready?
Yes!
Go ahead and start. And time. Pencils down. Who would like to go over the sprint for us, please? Brennan.
Okay.
Make sure you're on side A. If you've gotten the problem correct, what should you say?
Yes!
All right, Brennan, go ahead.
8 times 1, 8. Yes! 1 times 8, 8. Yes! 8 times 2, 16. Yes! 2 times 8, 16. Yes! 8 times 3, 24. Yes! 3 times 8, 24. Yes! 8 times 4, 32. Yes! 4 times 8, 32. Yes! 8 times 5, 40. Yes! 5 times 8, 40. Yes! 8 times 6, 48. Yes! 6 times 8, 48. Yes! 8 times 7, 56. Yes! 7 times 8, 56. Yes! 8 times 8, 64. Yes! 8 times 9, 72. Yes! 9 times 8, 72. Yes! 8 times 10 is 80. Yes! 10 times 8 is 80. Yes! 1 times 8 is 8. Yes! 10 times 8 is 80. Yes! 2 times 8 is 16. Yes! 9 times 8 equals 72. Yes! 3 times 8 equals 24. Yes! 8 times 8 equals 64. Yes! 4 times 8, 32. Yes! 7 times 8, 56. Yes! 5 times 8, 40. Yes! 6 times 8, 48. Yes! 8 times 5, 40. Yes! 8 times 10, 80. Yes! 8 times 1, 8. Yes! 8 times 6, 48. Yes! 8 times 4, 32. Yes! 8 times 9, 72. Yes! 8 times 2, 16. Yes! 8 times 7, 56. Yes! 8 times 3, 24. Yes! 8 times 8, 64. Yes! 11 times 8, 88. Yes! 11 times 8, 88. Yes! 8 times 11, 88. Yes! 12 times 8, 96. Yes! 8 times 9, 8 times 12 is 96. Yes! 30 times 8, 104. Yes!
Excellent job, Brennan. All right. Go ahead and flip it over to side B. Side B is the same concept. You have 60 seconds to answer as many as you can. Ready, set?
You bet!
Let's go. I really like how certain students finished early and they took the time to go over their work to make sure that they double checked what they were doing. Zion, do you mind going over side B for me, please? Don't forget to read the whole problem. Okay. Ready, set?
You bet!
You should have I on page.
8 times 1 equals 8.
Yes!
8 times 1 equals 8.
Yes!
2 times 8 equals 16.
Yes!
8 times 2 equals 16.
Yes!
3 times 8 equals 24.
Yes!
8 times 3 equals 24.
Yes!
4 times 8 equals 32.
Yes!
8 times 4 equals 32.
Yes!
5 times 8 equals 40.
Yes!
8 times 5 equals 40.
Yes!
6 times 8 equals 48.
Yes!
8 times 6 equals 48.
Yes!
7 times 8 equals 56.
Yes!
8 times 7 equals 56.
Yes!
8 times 8 equals 64.
Yes!
9 times 8 equals 72.
Yes!
8 times 9 equals 72.
Yes!
10 times 8 equals 80.
Yes!
8 times 10 equals 80.
Yes!
8 times 3 equals 24.
Yes!
1 times 8 equals 8.
Yes!
2 times 8 equals 16.
Yes!
10 times 8 equals 80.
Yes!
9 times 8 equals 72.
Yes!
4 times 8 equals 32.
Yes!
8 times 8 equals 64.
Yes!
8 times 3 equals 24.
Yes!
7 times 8 equals 56.
Yes!
8 times 6 times 8 equals 48.
Yes.
8 times 10 equals 80.
Yes.
8 times 5 equals 40.
Yes.
8 times 6 equals 48.
Yes.
8 times 1 equals 8.
Yes.
8 times 9 equals 72.
Yes.
8 times 4 equals 32.
Yes.
8 times 3 equals 24.
Yes.
8 times 2 equals 16.
Yes.
8 times 7 equals 56.
Yes.
8 times 8 equals 64.
Yes.
11 times 8 equals 88.
Yes.
8 times 11 equals 88.
Yes.
12 times 8 equals 96.
Yes.
8 times 12 equals 96.
Yes.
13 times 8 equals 104.
Yes.
Excellent job. Thank you, Zion. Thank you, Brennan, for modeling that for us. Make sure your name and date is on both sides. You know how to total up your number correct. Take about 30 seconds to do that. Once you're finished totaling those up, go ahead and give your paper to your group leaders. And Trinity will come around to each group to collect those and give those to Mrs. Wills. All right, go ahead and pass those into your group leaders, friends. Pass them in now. Let's go. Excellent job. Go ahead and get those books and stack those up for me, please. I like the way Braden's group is on task. Lizzie's group has quickly turned in all of their papers. Everyone needs to grab a marker out of their bucket. We're going to continue with our fluency practice by multiplying 3 and 4 digits by 1 digit. I'll wait for everyone to get ready. Once you have your markers, I need your attention up here. First of all, I want to thank this entire group because you all have worked so hard this school year on learning those multiplication facts and mastering those multiplication facts. One thing that's going to be a benefit to you all is we're moving into area and perimeter, and we're moving into multiplication with partial product, word problems. So that is going to be such an advantage to you as we move into second quarter. You did a phenomenal job first quarter, and I have no doubt that we're going to continue our work through the second quarter. We have 4 problems up here. What I'm going to do is I'm going to let you work these through in your groups, and then we're going to go over them together before we go into our concept development. We will be working in centers today. So let's make sure that we are on task. If you have questions, don't hesitate to raise your hands. Group leaders, continue to do the work that you've done throughout first quarter. Take about 2.5 to 3 minutes to work out these 4 problems in your groups. Are you ready? Ready, set.
You bet.
Let's go. I like how you guys are using partial product to check your work, but we're using standard algorithm on that, so just go ahead. We're not about another minute or so, but we're doing standard algorithm. All right, we're going to go ahead and go over these just for the sake of time. I like how Aiden's group was finished, so they used their time to use partial product to check their work. We're just using standard algorithm for our fluency practice. Standard algorithm is just the basic way that we multiply. We're not applying the partial product because this is just a warm-up strategy. We have our first number is 773 times 2. If we didn't want to use multiplication, what's another way that we could solve this problem? Susie?
We could use addition.
We could use repeated addition. But since we know multiplication is a quicker way to find our product, we're going to go ahead and use that multiplication. So 773 times 2. What is 3 times 2, class?
6.
What is 2 times 4?
14.
Excuse me, 2 times 7?
14.
I put my 4 down, regroup my 1 into the?
100.
And what is 2 times 7?
14.
Plus 1?
15.
All right, I want you to turn and talk. Where does my comma go, and what's the value of each digit? Ready, set.
You bet.
All right, where does my comma go, Omar?
To the thousand, hundred.
Beautiful job. I like the way you used place value. He said between the thousands and the hundred. Who wants to call my values? Nikki.
What's the value of our 1? 6. What's the value of our 10? 40. What's the value of our 100? 500. What's the value of our 1,000? 1,000.
Very good job. Who got 1,546 for a product? Beautiful job. The next one, we have 147 times 3. What is 7 times 3?
21.
I put my 1 down, regroup my 2 into the?
10.
Excellent job. What is 3 times 4?
12.
Plus 2?
14.
I put my 4 down, regroup my 1 into the?
100.
What is 3 times 1?
3.
Plus 1?
4.
Again, talk about the value. What is our product and what's the value of each digit? Ready, set? All right, Brandon, call out my values for me, please. We have a product of 444.
What's the value of my 1? 1. My 10. 40. My 100. 400.
Now we have 2 4s here. We have 2 4s. Which 4 has more value, Kainis, and why?
The one in the hundredth place because that's 400 in the one in the 4 in the tens and only 40.
Right. Remember, every time we go 1 place to the left is a 10 times greater. The value of the place is 10 times greater. Who wants to take the next one for me? 1,605 times 3. Elizabeth, go ahead and take this. You guys are doing an excellent job. Remember, practicing those multiplication facts home with your parents, with your family. When you're not at school, it's going to make you a stronger math student while you're in school. Go ahead, Elizabeth.
1,605 times 3. What is 5 times 3? 15. Drop player 5 down, regroup our 1 into the 10. What is 3 times 0? 0. 1. 1. What is 3 times 6? 18. Put our 8 down, carry our 1 to our thousands. What is 3 times 1? 3. 4. What is our common go, Trinity?
In between the thousands and the hundreds.
Is our answer reasonable, Brandon?
No. Yes.
How is it reasonable, Naya?
It's not reasonable because we didn't do partial product.
Well, it is. We're not checking with partial product right now, but who can tell me why it is reasonable? Trinity.
It's reasonable because we multiplied it by its face value and we got the answer, which is 4,815.
Very good. And Anaya, you're not wrong. In fact, I like what you had to say because what you're saying is we didn't check our work using partial product, but we're just doing standard algorithm for right now. What's the value of our ones place? Thank you, Lizzie. 5. What's the value of our tens?
10.
What's the value of our hundreds?
800.
And what's the value of our thousands?
4,000.
Trinity, you want to take the next one for me, please? 5,741 multiplied by 5.
What is 1 times 5?
5.
What is 4 times 5?
20. Hundreds.
7 times 5.
35.
Plus 2.
37.
Okay, down by 7, carry our 3 to the
Thousands.
5 times 5.
25.
Plus 3.
28.
Where do we put our
Turn and talk. Where does our comma go?
In between 1,000 and 100.
Thank you, Trinity. Where does our comma go? I'll go ahead and take that, sweetheart. Thank you. Abigail, where does our comma go?
In between the thousands and
In between the hundreds and the thousands. Very good. What is our product, class?
48,705.
All right, 28,705. What's the value of my ones place?
5.
What's the value of my tens place?
0.
What's the value of my hundreds place?
700.
What's the value of my thousands place?
8,000.
And what's the value of my 10,000s place?
20,000.
Well, you know what I'm going to do? Since you said that 0 has no value, I'm going to go ahead and erase it.
No.
I need to put it back?
Yes.
Why don't you turn and talk to explain why I need to put that back? Why do I need to put my 0 back? Okay. That makes sense. Let's go, Rockets! Let's go, Rockets! Why do I need to put that 0 back? Kainis?
Because the placeholder for the 10.
It's a placeholder for the 10. So therefore, if I erase that 0 because it has no value, it will change the entire number and it is holding the place for the 10s. Very good. Why don't you give someone a high five or a fist bump while we transition? All right, you all have your Eureka books. Go ahead and get your Eureka books passed out. They're already at your tables. No, they're already at your group. Just grab anyone, like for real. It might already be done. All right, I need everybody's attention up here. Boys and girls, like I explained earlier, for today's lesson, we are going to use addition and subtraction, multiplication to solve multi-step word problems. And when I say a multi-step word problem, what exactly does that mean? Susie?
It's like a word problem that has many steps to it before you find your answer.
Beautiful job. Can you say that a little louder so everyone can hear?
A multi-step word problem is a word problem that has many steps to it before you find your answer.
Very good. And today, a lot of our problems are going to have 2 or 3 steps to it. All right? So for our concept development, boys and girls, we're actually going to use our problem sets, which can be found on page 69. So go ahead and turn to page 69 in your Eureka book. I love word problems because we get to use one of Eureka's most popular strategies, and that is the RDW strategy to model problems. What I want you to do, I know we just came off a fall break, let's just freshen up our brains and talk about in your groups, what is the RDW process and how do we use it? Go ahead and talk about that now. So the R represents what? Read the problem. What does the D represent? A chart, tape diagram, okay. A sentence. Right, you have to, very good, explanation. So read the problem, draw a chart or diagram, and write a sentence. Very good. Very good. Thank you for those of you who are responding. The RDW process, what does that represent? Let's start with the R. Aiden.
R and RDW, R means to read.
You have to read the problem. And that's why it's so important to pay attention in reading class, because math is reading and reading is math. We are moving into large word problems to where you're going to have to figure out which operations we're going to use. So read the problem. What does the D represent? Abigail.
Draw.
You can draw. What are some of the options we have with our Eureka program? Yes.
You could draw a tape diagram.
Very good. You can draw a tape diagram, and we use those quite a bit in Module 1 and 2. What else can we use? Ariana.
We can use it to show our work for our addition problems and subtraction problems.
Right, the tape diagram. What's another strategy we can use? Trinity.
A number line.
A number line, a chart, okay? So we're going to read the problem. We're going to draw a number line or a tape diagram or a chart to help us solve the problem so we get that visual. And what does the W represent, Asiane?
The W represents right.
Right. What are we going to write? Who wants to give me more on that? Kyanese.
Like you could write a statement that goes with the problem, that the answer.
That is very correct. You never want to solve a word problem without answering the question that's being asked. And writing a statement to solve that equation wraps up your problem and makes sure that you're solving it correctly. Okay? So, what we're going to do is we're going to read the problems, we're going to use the RDW process, and we're going to calculate and solve, and we're definitely going to check to see if our work is what? Reasonable. You have to be able to discuss why your work is reasonable. So, what I have here, the same word problem that you have in front of you, we're going to use 3 word problems for our lesson. These word problems are for your problem set today, and as you rotate into Mrs. Wills' small group, we will work on a few more word problems. The last one in our book, and I have some additional ones that I've created from the Eureka program. So, who wants to go ahead and read this problem for Mrs. Wills, and we're going to figure out what we can do to solve it. Let me see, Brianna, go ahead.
Over the summer,
Can you read loudly, please?
Kate earned $180 each week for 7 weeks. Of the money, she spent $375 on a new computer and $137 on new clothes. How much money did she have left?
Very good. We have numbers and we have information. We don't ever want to solve a problem before we pull out that important key information. Why do we pull out key information before we solve a problem? Brennan?
So we can break it down.
So we can break it down. I love how you stated that. We have to break it down, but we have to look to see what information we're going to use. So in your group, take about 30 seconds to talk about what am I going to circle, what am I going to put a box around, what is going to help me solve this problem. Is that better? So go ahead and circle that information as you talk about it. Ready, set! You bet! I said ready, set! You bet! All right, what information did you circle or box? LaParis.
Kate earned $180 each week for 7 weeks.
Very good. Well, the 180 and the 7 weeks, is that important information?
Yes.
Will we use this to solve our problem?
Yes.
How about Faith? What else did you circle?
We have to circle. She spent $375.
Excellent. She spends $375.
And on computers, $137.
Very good. So we have the 180, the 7 weeks, 375 on a new computer, 137 on new clothes. Is there more? Braden.
Yes. It's how much did she have left?
That is probably the most important thing. How many do you have that underlined? That question. That question needs to be answered. Okay? So what we're going to do is, our first step is, we need to figure out, go ahead and draw a tape diagram. Let's start with a tape diagram. Okay? The whole amount is going to be what Kate earned. What are we going to have to, what equation are we going to have to use? I'm sorry, what operation are we going to have to use to see how much Kate earned over those 7 weeks? Talk about that in your group. Take about 15 seconds. What equation are we going to use? Okay, so first step, do we believe that that's what we have to do? We have to multiply? Okay. Yes. What's going to be our first step? What's going to be our first step? Zion. We have step 1 over here. What's going to be our first step?
Our first step is to multiply 180 times 7.
Very good. 180 represents how much she earned, and the 7 represents what? The amount of time that she worked. So 180 times 7. Stack that up. We have a 3-digit by 1-digit multiplication problem. What is 7 times 0?
0.
What's 7 times 8?
56.
I put my 6 down. I regroup my 5 into the 100. What is 7 times 1?
7.
Plus 5.
12.
Very good. So I have a total of $1,260. This is the total. This is what is the total here on this tape diagram. What we solved is 180, times 7. So the total amount we know is $1,260. All right? What information was given to us so we can go ahead and partition this tape diagram and account for those numbers? Ariana, give me one.
Well, we're going to need to add the numbers that she spent.
Right, but she spent how much?
375.
And 137. Now, I am just going to go ahead and partition a portion of that tape diagram to show the 375. And I'm also going to partition to show the 137 because those amounts are accounted for. Now, there's more than one way we can solve this, but I like the way that Ariana suggested to solve it. We know that I have heard many of you say that we're going to use subtraction as well. But let's go ahead and add up these money amounts that was spent. We have 375 plus 137. Okay?
Is that our step 2?
Yes, that is our step 2. It's just pushed over. Step 1, we multiply to find that total amount. In step 2, we're going to add what she spent on a new computer and on her new clothing. What is 5 plus 7?
12.
I put my 2 down, regroup my 1 into the
10.
Very good job, boys and girls. What is 7 plus 3?
10.
Plus 1?
11.
I regroup my 1 into the 100. 3 plus 1 is 4, plus another 1 is 5. She spent a total of $512. Okay? Take a moment to talk about it. We still have another step. What step are we going to do to figure out how much money does she have left? How are we going to figure this out? Very good. Is that reasonable? Okay. Hey, Shanae, what's going to be our next step, please, for step 3?
We're going to take our totals that we got from multiply 180 times 6.
Okay, we're going to take our total, she said, from step 1, which is a product of 1,260. And what are we going to do with that?
Then we're going to subtract it from the totals that we just added from the computers and clothes.
There's several things that's really important. It's important to line up our digits correctly when we're adding or subtracting or multiplying. Why is it important to are my digits lined up correctly?
Yes.
Why is that important, Nicole?
Because if we put the smaller number on top and the bottom number and the bigger number on the bottom, you can't take away the smaller number from.
Very good. We have to make sure our larger number sits on top. What's another reason why we have to make sure they're lined up properly? All right, Sandy.
Because you might get the wrong answer if you're in the wrong spot.
Exactly. If you have your numbers in the wrong column, you definitely will get the wrong answer. So let's go ahead and subtract this out and see how much money Kate had left. Can we take 2 from 0?
No.
Okay, so we have to go next door. That's 6. We're going to borrow, and that becomes a what?
5.
All right. The 0 becomes a 10. What is 10 minus 2? 8. What is 5 minus 1? 4. Can we take 5 from 2? I'm sorry. All right, so what do we need to do next on this, Abigail?
We need to borrow from the thousands.
I like the way you use that place value. Excellent job. We borrowed from that 1, now that's a 0, and the 2 becomes a 12. 12 minus 5 is? 7. Very good job. $748 is what she has left. But you want to know something? I'm not really happy with that answer. I think there's a way that we can check to see if our answer is reasonable. I want you to talk about what we can do to check to see if it's right. What would you do? All hands should be up when I hit my chime. Thank you. Excellent job. Who wants to explain to me what we would do? Aiden.
We have to check our work by adding 748 and 512.
Very good. That's called a what? A reverse what?
Operation.
A reverse operation or a reverse strategy. If we did our calculations correctly, if we add 748 and 512, we should get our original product of 1,260. Am I correct?
Yes.
All right, what is 8 plus 2?
10.
I root my 1 into the 10s. What is 4 plus 1? 5. Plus 1?
6.
And 7 plus 5?
12.
Does it match?
Yes.
Does it match?
Yes.
Because those answers match, what does that tell us? Can we move on?
Yes.
Did we do a good job?
Yes.
Awesome. Give someone a fist bump, a high five, and a compliment.
Good job. Good job. Good job. Good job. You're being such a good teammate. Good job. Good job.
All right, we're moving on to the next one. Kainis, do you mind reading this problem for me, please?
Sylvia weighed 8 pounds when she was born. By her first birthday, her weight was tripled. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. What was Sylvia and her dad combined weight?
Very good. So we're figuring out how much. Actually, the question that needs to be answered is what was Sylvia and her dad's combined weight? Before I release you to figure out what that key information is, I'm just going to let you know that we're going to switch it up. We're going to use a different Eureka strategy. We're going to use a chart. The beautiful thing about math is you can use whatever strategy you'd like. If you want to use a tape diagram, you can do that. But for the sake of going over this together as a whole group, let's use a chart. All right? So what do you think the chart that S represents? Sylvia. What does the D represent?
Dad.
And what does the T represent? Total. Take a quick second, figure out what is our key information, talk in your groups, and we'll come back together. What's the key information over here?
key information is that her weight had she weighed 8 pounds when she was born. So we have to multiply 8 times 3.
Ready, set? You bet. All right. So tell me, what information, Christopher, did you circle or underline?
I underlined what was Sylvia and her dad's combined weight.
Very good. We underline that. What is Sylvia and her dad's combined weight? But let's go back into the problem. What is that key information? Faith, give me one bit of key information. What is some of that key information that we need to circle?
Circle your numbers.
Very good. So we have 8 pounds. Also, there's something else here in this next sentence that is really important for us to pay attention to. LaParis.
She tripled.
She tripled her weight. And when you think about tripled, what comes to mind for you? What number?
3.
3. What are some things that come in threes? Yes. A set of triplets. A tricycle has how many wheels? 3. All right. So when we see triple, what about if it was double? What number would you think of? 2. So pay attention. And if you notice, tripled is not in standard form. It's in word form. So another example of why it's important that we read properly and read accurately. By her second birthday, she had gained 12 more pounds. Hopefully you circled that. At that time, Sylvia's father weighed 5 times as much as she did. So we're going to circle the 5 times as much. Raise your hand if that's the information that you circled and you got all of it. Okay? So step 1, we need to figure out how much Sylvia weighed. Okay? So what are we going to set up? What operation are we going to set up to figure that out? Nicole?
8 times 3.
8 times 3. I can agree with that. Does anyone agree with that? Give me a thumbs up. All right? We all know that 8 times 3 is what?
24.
24. However, the 3 represent, like LaPera said, that it tripled. At birth, she weighed 8 pounds. It tripled. We multiplied that by 3. Now we have 24. But it says she had gained, by her second birthday, she had gained 12 more pounds. That keyword more falls under which operation?
Multiplication.
No. Addition. Very good. So we're going to add those 12 pounds. Okay? What is 4 plus 2?
6.
And 2 plus 3?
3.
I'm sorry, 2 plus 1?
3.
Very good. So, how many of you knew that LBS is the abbreviation for pounds? Did anyone know that?
Yeah.
Okay. So 36 pounds is what Sylvia weighed by her second birthday. That's step 1. Make sure you have that on your paper. Make sure you have that in your booklet. Now for step 2, we have to figure out how much Dad weighed. Talk in your groups. How can we figure out how much Dad weighed? What operation are we going to set up? Very good. Excellent. Class.
Yes.
What's our next step? Step 2. Every group that I stopped by heard accurate information. What's our step 2? Kinsey.
Our step 2 is to find out how much Sylvia's father weighed, which is 5 times as much. So we're going to add 35 times 5 to 36.
So we're going to do 36 times 5. Very good job. We could do repeat addition. 36 plus 36 plus 36 plus 36 plus 36. That takes too long. It's a more effective way to use multiplication. All right? What is 6 times 5?
30.
I'm going to regroup my 3 into the tens place. Very good. 5 times 3?
15.
Plus 3?
18.
Very good job. How much did Dad weigh?
180 pounds.
180 pounds. Did anyone get that on their own? Yes? Now, we're going to finally get to the point where we have to answer that question. The question, they want to know how much was her combined weight with her dad. What does the word combined mean? Can you give me a synonym for the word combined? Talk about that in your group. A synonym for combined. I like that one. What is a synonym for combined? Yes. Together. All right. Let's put it together. Let's combine it together. So with that said, we have two weights. We have 180. Step 3, 180 plus 36. Check to make sure your digits are lined up properly so you get the proper sum. What is 6 plus 0?
6.
8 plus 3?
11.
I put my 1 down, regroup my 1 into the hundreds, and 1 plus 1 is 2. I got a total of 216 pounds, thank you, for both Sylvia and her dad. But you know what? We need to come up with a statement. So in your booklet, come up with a statement, and then we'll share out some of the statements that you came up with. You have to come up with a written statement. Who wants to share their statement? LaParis.
Sylvia and her dad weighs 216 pounds altogether.
Very good. Sylvia and her dad weighs 216 pounds altogether. Zion.
Sylvia and her dad weighs 216 pounds combined.
I like the way you said that also. Sylvia and her dad weighs 216 pounds combined. If you have something totally different than these two scholars, you can raise your hand. Yes.
Sylvia and her dad weigh 260 pounds altogether.
Very good. Excellent job. Give someone a high five, a fist bump, and a compliment. Nice job. All right, boys and girls, for the sake of time, I am going to continue on with this lesson, working through word problems in my small group. What I would like for you to do, and you're going to have 30 seconds. I'm looking for, just hold, for those groups that can do this quickly and efficiently. If you are not working in my small group right here, you know what to do. Stack your books and give them to your group leader. You have 30 seconds to get your station set up.
Okay, so how do we find our formula of the area, Brayden?
By width times length.
Nice job. What would we have to multiply?
18 times 18.
Let's do it on our board and then convert it to our paper.
Let's do it on our desk. 8 times 8.
64.
Drop the 4. Carry 6 to the 10. 8 times 1. 8. Plus 6. 14. Drop the 4. Carry the 1 to the 100. 98. 14. 76. What's your answer? 74. Good job.
What are we running with? 34,826.
To make it a shorter way.
30,000. 30,000. Yes. 40,000. 35,000.
The 2 becomes
400 and 300. So, are we rounding up or down? We know we're rounding up because when we look at the 2 places, 3 is not better than 354,350. So, tell me when to stop. Stop. Okay.
Circle your one that you rounded.
Okay. And make sure you try. Just, you know, this 32 hours. How are we going to do this? Everybody finish. 54. What are we going to say? What's the value of my 100? So what will be my bottom benchmark?
Who wants to lead this one? Kenzie.
So we do stop.
0.
We do 19.
48. Put my 8 down. Regroup the 4 into the hundreds. 24. 24 plus 4 is 28. Very good. We put our comma where?
Between the values and the hundred.
Very good. Who wants to do values for me? All right, Sandy. 0. 80. 800. 2,000. Very good. Brennan, you can come up here and we'll get started. Brennan and Angelique.
120. 96.
Christopher.
24. 35. 0.
Very good job. Susie?
24.
She actually wasn't looking. We'll do that again.
28.
Very good job. Miss Bryant and Trinity. I shouldn't hear anything back here, guys.
36. 1.
Trinity and Xavier.
1 to 20.
Trinity and Liliana.
81. 22.
Trinity and our Sandy.
0.
Trinity and Kenzie.
32.
Very good. Kenzie and Zion. Awesome work.
110.
Kenzie. Okay, very good. Give Kenzie a hand, please, friends. Awesome job.